Good morning, everyone. Myself Sneha Purbia from Group 316. Here is my topic, the hydrogen bond and the structure of water. Let's start with the water chemistry. All living organisms are depend on a water. The structure of a water is the basic of its unique properties. The most important property of water is the ability to form a hydrogen bond. Within a water molecule, the bond between oxygen and hydrogen are highly polar. The partial electrical charges developed on a water molecule is the partially negative charge that's developed on a oxygen atom and the partially positive charge that develop on a hydrogen atom. Here is the transition. Here we can see that the oxygen have a partially negative charge and a hydrogen atom having a partially positive charge. Now let us talk about hydrogen bond. Hydrogen bonds are the weak attraction between the partially negative oxygen of a one water molecule and the partially positive hydrogen of a different water molecule. Hydrogen bond can form between a water molecule or between the water and another charged molecule. Example: oxygen with hydrogen and nitrogen with hydrogen. The hydrogen bond reveals itself distinctly in optical spectra and NMR spectra. The characteristic vibration frequencies of groups containing a hydrogen bond, says OH and NH groups, decreases if hydrogen forms hydrogen bond. Example, in a monomeric formic acid. Here is this formula of the monomeric formic acid. The vibrational frequency of the oxygen OH is decreases after this dimer formed, which is stabilized by the hydrogen bond. Another frequency of monomer are also changed. The infrared absorption bond of OH group are strongly bonded when the hydrogen bond formed, and then their intensities are enhanced. The hydrogen bond energy is determined from the thermodynamics properties of the substance from which their spectra. The thermodynamics functions are expressed in the term of equilibrium constant. Here is the formula. K is equal to activity of substance upon product of activities of reagent. We can write also in this form also. This the square bracket signifies the concentrations. The free energy of formation of hydrogen bond is given by the delta G is equal to delta H minus T delta S, which is equal to minus R T ln K, where change in H or delta H is known as a enthalpy, and change in S that known as a entropy. Uh, the hydrogen bonding invariably links together two electronegative atoms. The hydrogen atoms not shared by the atom of A and B. This from this equation, um, the the solid line denotes the covalent bond, and this dotted line represent the hydrogen bond. If we are talking about the H2O system, the covalent bond is much shorter than the hydrogen bond. This also signifies that this covalent bond is more stronger than the hydrogen bond. We Here is this transition which is happens normally in a water molecule. The hydrogen bond is complex. Its energy made up of a contribution from electrostatics, dispersion, and the quantum mechanical interactions. These quantum mechanical interactions is determined by dislocation of the proton and the electrons. Now let us talk about the structure of the water. The structure of the water and ice is determined by the hydrogen bond. A water molecule can form four hydrogen bonds within a neighboring molecule, which are tetrahedral coordination. Ordinary ice has hexagonal crystalline lattice, each oxygen atom in lattice residing in the center of the tetrahedron, at the apex of which there are located the neighboring oxygen atoms. The O2 distance is equal to 0.276 nanometer. The elementary unit cells has a 4 molecule. The molecular lattice of ice is very loose with large open channels. Since its coordination number is very small, that is 4, this explains why ice is less than the water. The property of ice is not unique, it is also exhibited by the crystal of diamond, silicon, and germanium, which have a similar structure. The ice-like structure is written also in the liquid water. The number of broken crystalline portion being the greater and the higher the temperature. Speaking of the structure of a water, the one should take into account the time scale in which this structure is recorded. In the ice structure, the water molecule experiences the vibration, rotation, and occasional transition displacement. A snapshot taken with exposure to the time uh, are much shorter than the period of vibration. Means time vibration is equal to the 2 into 10 power minus 13 second. Displays an instantaneous or a M structure during the time, much longer than the time vibrational, but considerably shorter than the time of the rotational diffusion, which is equal to the 10 power minus 5 second. The randomly oriented molecules are formed, which we can say that these are known as the K structure. In ordinary experiment, time is more than the time of diffusion. We can also say that means diffusion averaged K structure is obtained, which we know that it's also known as the D structure. If we are talking about the liquid water, the in the liquid water, the M and K structure are similar to the crystalline structure, but the D structure is smarted by the displacement of the molecule. If we place metally the camera over the water molecule and record this surrounding water molecule during motion, we shall obtain the D structure of the liquid, which is averaged K structure. Just see this. This is the vibrational average structure. Then this is the diffusion average structure, and this is the structure of a water. Then using various method of investigation with different duration of experiments time, we can obtain information on the various types of structure. The thermodynamic properties naturally characterize the D structure of a liquid. The coordination number of water is 4.4. Thus water is a quasi crystalline, and each molecule has on an average 4 neighbors. A number of theoretical models of a water structure proposed explain that it is a far difficult to decide on any one structural picture of a liquid water. But we can consider the interpretation of the most important physical properties of a water, and in the first place, it's depend on a specific volume on temperature to have been established. The minimum of specific volume at 4 degrees Celsius accounted for by the competition between two processes. The first process is the collapse of the ice open structure with a small coordination number, that is 4, causing the decrease in the volume. This is a continuation of the melting process. And the second process is the which predominantly up to a temperature is more than 4 degrees Celsius. It is a thermal expansion of a liquid. This is liquid due to an increase in the amplitude of an harmonic intermolecular vibration. This is all about the hydrogen bond and the structure of a water. Thank you.